Hello, my name is Mohammed Yunus. Today I am presenting and explaining the content given by the NFPA for my CFI 1 and NFPA 72 fire alarm and signaling code instructor. So I have many topics given by the NFPA. So let's start. First topic is plume flow and fire ceiling jet flow. So what is plume flow? A fire plume flow is a combination of a hot gas, smoke and combination rising directly to the fire. Hot gas and smoke are lighter than air, so they have a tendency, this is a fire, they have a smoke air, so they have a tendency to go upside because it is lighter than air. And this is a structure, for example, this is ceiling. When this go up, this is called plume flow. Then hot air will go up. What is ceiling jet flow? Ceiling jet flow, when this is hot air and smoke will rise and touch the ceiling. So it will contact with the ceiling, then it will move to the horizontal. This is called ceiling jet flow. Why this is very important characteristic in our detection and selection of the smoke detector, heat detector, where we will install the smoke detector and heat detector. So this is the first topic, and second topic is ambient temperature and humidity. Smoke detector will not be installed if the following condition will occur. The conditions are if the ambient temperature is less than 0 degree centigrade. Second condition, if the ambient temperature above than 38 degree. Third condition, humidity, if the relative humidity is greater than 93 degree percentage. So these are the condition. And what is ambient temperature? Ambient temperature means like in this room we have about normal temperature. When we will read by the temperature scaling measurement scale, so it will take for 60 seconds, and we will consider the maximum temperature within the 60 seconds. So this is normal temperature in the rooms or any space is called ambient temperature. So this is our second topic, and third topic is that ceiling shape and surface. So what is ceiling shape and surface? Normal type of ceiling is this is called ceiling. This is normal ceiling. So, and we have an irregular type of ceiling. This is irregular type of ceiling. So smoke detector or heat detector will be installed as per nominal listed spacing. Nominal listed spacing as per NFPA is 9.1 meter, 30 feet. So here we will install the detector, and this ceiling, each point of the ceiling shall be covered by this detectors. So this is called nominal shaping. In irregular shape, we will install the detector, for example here. So it should be covered same like in the nominal spacing, but this irregular shape should be 0.7 times of the nominal spacing. So we always consider this is half of the space, and this is 0.7 times of listed spacing. So same we will consider always 0.7 times. So this is all we have to consider based on ceiling shape, irregular ceiling shape, and normal ceiling shape. Our fourth topic is like in ceiling shape, we have this type of ceiling. If the slope is less than 30 degree, so what we will done, and in same cases the ceiling space is greater than 30 degree. So what we will do in this case, will be installed in the peak location, peak height of this location. In this case, detector will be installed in the peak ceiling, and not a relative detector. Remaining detector will be installed the average sloping height of the ceiling, and this all will be covered within 36 inch from the 36 inch not degree, inch from the ceiling. So our fourth topic is ceiling height. As NFPA said that 0 to 10 feet height will be considered as a normal height. So any type of heat detector or smoke detector spacing, we will consider here heat detector spacing as per the table 17.6.3.5.1. So smoke detector spacing will be reduced if height increase. So for example, here more than 10 feet, for example 10 feet to 12 feet, 20 feet to 22 feet, what we will do? The normal case is here, the normal spacing is 30 multiplied by factor 1. Here in this case, what we will do? In this case, the normal spacing is 30 feet and the factor here is 0.58. So we will continue this 0.58. So detector will be installed based on this ceiling height, and spacing will be reduced when the ceiling height will be increased. Our next topic is number 5. Number 5 topic is fuel and its configuration. What is fuel? Any material when it will burn, it generate fire plume, and like material is like flammable liquid, combustible solid, gaseous fuel. Each type of fuel produce different type of heat release, different type of smoke production and plume characteristics. So fuel configuration is like the combination of smoke, heat, and this arrangement of this fuel sources. Like we have a points type of source, area type of source, and natural sources. This all will be considered when the detector will be installed. The response time and the spacing all will be considered based on this. Now we have another topic, number 6. Number 6 is ventilation. What is ventilation? Ventilation is movement of air. The ventilation means movement of air from this inside room to outside room. So we will check. The ventilation can dilute, temporary delay smoke particle to reaching the detectors, like ventilation, like HVAC system. So what we will do in this case, we have to install the smoke detector at least 36 inch from the diffuser, and HVAC system shall be shut down in case of any fire, so it will stop the spread of the smoke or fire. Detector shall be installed in the return air depth detector. This is called ventilation. So our next topic is number 7, smoke stratification. What is smoke stratification? Smoke stratification is a phenomena of fire protection engineering, where smoke have a tendency and temperature different from it create a different type of layer in the space in the ceiling and accumulate near to the ceiling. For example, we have this type of shape like warehouses. Here fire will happen, smoke will rise. They have hot air, smoke, and they have a normal temperature in the environment. So when this hot air will go up, it will contact with the surrounding air, and the surrounding air will, what we will do, surrounding air will do to cool down this air. When this is cool down the air, it will not reach to the ceiling. So what happens? It will create a layers in between the surface at certain height. So this will create this is called smoke stratification. Type of factor we will consider, type of factor for smoke stratification, like is tendency and temperature difference from surrounding temperature and hot air. And second is the ceiling height, when smoke will create from this fire. So it have a ceiling height is very high, so it have a long vertical path to travel from this smoke there to reach this ceiling. So what happened, because of this cool temperature, it will create the layer before it reaching to the ceiling. If the ceiling height is very high. Third is ventilation. I already explained. If we have any ventilation in the system, so what happens, the ventilation air will increase this smoke air. So this plus this hot air and the smoke ventilation, it will cool down the temperature and form this type of layer because of this. Now fire characteristics, fire size, shape, it will also a factor of consideration. When small amount of smoke will create, it will not reach to the ceiling. So this all type of factor we have to consider in smoke stratification. But what happen, what we will do, how it will be reduced smoke stratification. We have this shape, there is a fire. So what happen, factor to be reduce this, performance based design. So we have normally what we will do, pre-descriptive design. So don't go for the pre-descriptive design, we will go for the performance based design. And performance design, what will happen, will create artificial smoke air and check how many times, 5 times, 6 times, 10 times, to check where the layers will form, where the layer will form in this type of scenario, in this type of structure. So we will check the smoke stratification. Number 2 points, modeling, third party software modeling. Like we have a modeling type of software. So this software will create the smoke generally, and this will show us where and how much height it will create the layers, temperature difference, and the environment factor like temperature difference, HVAC, ventilation, all we have to be consider. And what we will do in this case, for example, we have a smoke detector on the ceiling height. So in this case, what we will do, we will add multiple layers before and after the stratification layers. So we have to add multiple layer of smoke detector, we have to install here multiple layer of smoke detector. We have to check beam detector, we have to install in many location based on the height. We have to check here beam detector here, beam detector here. So in any cases, it will go reach, it will activate this beam detector, it will activate this spot type of detector, it will go up, then it will activate this type of smoke detector. We have to install here base the system, aspirating smoke detection system. What happened, this air will calculate based on this. So this is called smoke stratification. So now we have to go for another topic. Another topic is like smoke detector. Normal type smoke detector have a nominal spacing 30 feet, 9.1 meter. Okay, but based on height, we have to consider height also. So this is also a factor for height to reduce the spacing between the detector. Third character, we have to check beam and solid joist. This also we have to consider between smoke detector placement, spacing, and this and that. So in this case, smoke detector, beam and solid joist. So in this case, for example, we have this type of space and we have a beam here. So if first condition, if this beam depth is less than the 10% of the ceiling height, 10% of this is ceiling height. So 10% of the ceiling height, what we do is consider a smooth ceiling, and detector will be installed either on ceiling, either on the beam of the bottom of the beam. Second scenario is that if the beam depth is greater than 10% of the ceiling height, so what we will check? We will check the spacing between the beam. So if spacing between the beam is equal or greater than 40% of the ceiling height, so what we will check? We will install the spot type detector in each pocket. We have to install in each pocket. Second scenario is that here, if the beam detector height is less than the less than the 40% of the ceiling height. In this case, what we will do, in this case detector will be installed uh, in the ceiling 50% and 50% of the perpendicular of the beam, perpendicular of the beam, and 50% smooth ceiling spacing in the direction of parallel to the beam, and 50% we have to install spacing perpendicular to the beam. So this is the third scenario. Now we have another scenario. For example, we have a direct beam and we have an intersecting beam in baffle ceiling or pen type of ceiling. So what we will do, if we have an intersecting beam, so if the ceiling height same is less than 10% of the height, so what we will do, consider smooth ceiling and detector will be installed bottom of the beam or the ceiling. And second scenario is, if the is greater than 10% of the ceiling height, so what we will do, we will I explained to you, we will follow the spacing. Detector will be installed in each beam pocket. And the third scenario is that for example, we have a corridor less than 50 feet width, this 50% less than 50 feet. We have a perpendicular beam of this ceiling, perpendicular beam for this corridor. So what happened in this case, this will consider the smooth ceiling, and detector will be installed either on ceiling, either on bottom of the beam, or either on the side wall. Second, we have a room less than 900 square feet. In this case, what we will do, this will consider the smooth ceiling spacing, and detector will be installed either bottom of the beam, if there is a beam, so bottom of the beam, or either on ceiling. So we have to check this. So this is all my topic today, and thank you very much.